Now let's take a look at independent and dependent probability. But before we go into that, let's quickly examine the product of multiplication law. So we multiply the probability of events when we are finding the probability of event 1, event 2 and event n occurring. The key word to note is and. When I was talking about the addition law, I mentioned that when you see or between events, you should know that you add them together. So now if you have multiple events, I want to find the probability of one event and another occurring. What you do is you multiply the probabilities of each of those individual events. So if there's one thing you should remember is that once you see and, know that you are multiplying. So now let's go to the idea of the independent probability. So two or more events are independent if the outcome of one of the events have no effect on the outcome of the other events. So if we think about even the word independent, what does it mean? It means that two or more events are not related, meaning that they don't affect each other. So let's take a look at the following examples. The first one is tossing coins. So imagine I take a single coin and I toss it and the head shows. Now I toss it for the second time and it shows a head also. Now I toss it again the third time and it shows head. And I toss it the fourth time and it shows head. Now I'm about to toss it the fifth time and I ask you, is it going to show the head or the tail, or which face is more likely to come out? Now either you choose the head or the tail, you are going to be wrong. And why is that? Because all these streak of red heads have no effect on what is going to come out, meaning that the probability of a head showing up here is still 0.5 and the probability of a tail showing up is still 0.5. So irrespective of the face that has turned up in prior choice, what turns up now is independent of it. So we say this kind of activity or this kind of event is an independent event. Take a look at replacement, probability with replacement. I'm going to illustrate this point with the use of examples. And finally, imagine winning a lottery ticket and running out of milk. You can see that there is no correlation between them, between winning a lottery and running out of milk. Since there is no link between them, we say that these events are independent events. So how do we calculate the probability for independent events? So the product law for independent events, if A and B are independent events, the probability of A and B occurring is given as probability of A and B is equal to probability of A times probability of B. What this means is that I find the probability of A occurring, I find the probability of B occurring, then the probability of A and B occurring will just be the product of those two numbers. So in general, the probability of events A, B and C and N occurring is given as, so the probability of A and B and C and up to N is given as probability of A times probability of B times probability of C times probability of N. So you keep multiplying when you are calculating the probability of both events occurring. So let's take a look at an example. A die is thrown and a coin is tossed at the same time. What is the probability of getting both a 6 and a tail? So we are going to solve this using two approaches. The first approach, we are going to try to solve it with the conventional method, and the second approach, we are going to try to apply the product rule. So using the first approach, we just write out our possible results. So for the coin, I can either have head or tail showing up, and for my die, I can have values from 1 to 6 showing up. So these are the possible outcomes. The head and 1 can show up, head and 2 can show up to head and 6. And for the tail, tail and 1 can show up, tail and 2 can show up, tail and 3 up to tail and 6. So I know that the total possible outcome will be equals to what? When I count all these possible outcomes here, I have 6 by 2, so I have 12 possible outcomes. Now, how many of those outcomes is made up of tail and 6? So if you look at it carefully, you can see that tail and 6 appear only once. This place over here, it appears only here, tail and 6. So that means tail and 6 occurs how many times? Just once. So the probability of having tail and 6 will just be equals to what? 1 over total outcome, which is 12. So now let's try to tackle this using the product rule. So using the product rule, This is clearly an independent event because no matter what the head shows, it in no ways affect what the die shows. So the coin and the die are independent of one another. So the probability of having a 6 and tail just because the probability of 6 times the probability of tail. So now when you have a die has 6 faces. So what is the probability of one of the faces showing a 6? You know that just equals to 1/6 because you just have one side with a face of 6 and the total number of faces is what, 6. So you have 1/6. Now when you toss a coin, what is the probability of the tail showing? Probability of the tail showing is equals to half because you just have one and you have two possible outcomes which include the head and tail. So you have half. So therefore the probability of having a 6 and tail just with the probability of having a 6, which is 1/6, times the probability of having a tail, which is 1/2, and when you multiply it you get 1/12. So as you can see, we got practically the same answer. So rather than trying to list out all our possible outcomes, we can just use this formula for independent events directly and evaluate our answers quickly. So let's take a look at another example. A box contains 4 white, 3 black and 3 red balls. So this is the box. You have 4 white balls, you have 3 black balls, and you have 5 red balls. Now if the first ball is drawn and then replaced, after which the second ball is drawn, find the probability that the first ball is red and the second is white. So now when you count the total number of balls in the basket, what would it be equals to? You have 4 plus 3 plus 5. So you have what, 12 balls. So the total number of outcomes is what? So there are 12 balls altogether. So the question asks you that if the first ball is drawn, so after it is drawn, it is then put back into this box. Then the second ball is drawn. Find the probability that the first is red and the second is white. So now we know that the probability of the first red and the second white is just because of the probability of red times the probability of white. And as I told you before, when you have replacement, as is indicated here that the first ball is replaced, so this is probability with replacement, you know that they are what, independent events. So what is the probability of picking the first ball as red? So that will just be simply how many red balls do we have in this box? We have 5. And how many balls do we have in total? We have 12. So we have what, 5/12. How about probability of picking the second ball? So when we have picked the first ball, which is red, we replace it back. So after we replace it back, that means the number of total balls there will still be 12. And now we know that total number of white balls is 4. So the probability of picking a white ball now will just be equals to what? Total number of white balls, which is 4/12. So what does this become? So this becomes what? Probability of having a red ball is 5/12 and the probability of having a white ball is 4/12. And when you simplify this, 4/1, 4/3, and you get what? 5/36. So the probability of picking both red as the first and white as the second is 5/36. Now let's take a look at this final example under independent events. So a box contains 4 white, 3 black and 5 red balls. So I'll write that out again. 3 white, 3 black and 5 red balls. If the first ball is drawn and then replaced, after which the second ball is drawn and replaced, after which the third ball is drawn, find the probability that all the 3 balls are the same color. So now what am I trying to do here? I'm trying to draw out 3 balls and I'm trying to find out the probability that 3 of them are the same colors. Now for the 3 balls to be the same colors, this is where we have to apply the addition and the product rule, and I will explain what I mean. So now for us to have 3 balls of the same color, there are 3 possibilities. It's either I have 3 white balls, so I have 3 white balls, or I have 3 black balls, or I have 3 red balls. So now what do I talk about when I'm saying when we are dealing with or when we are having or? it means that I have to add the probability of having 3 white balls, my all remain plus my probability of having 3 black balls or my probability of having 3 red balls. So now I'll start out by calculating the probability of having just 3 white balls. So since we have replacement, we know that this is clearly an independent invert. So now we can write out that the probability of having a white ball will just be equals to total number of ball is what, 12 balls. The probability of white will just be 3 over 12. Probability of black will just be what? Sorry, white will be 4 over 12. There's a mistake here. Probability of black will just be 3 over 12, and the probability of red will just be 5 over 12. So now the probability of having 3 white ball, white will be equals to what? 4 over 12. We multiply each of them individually times 4 over 12 times 4 over 12 based on our product rule. And what does that give us? That gives us 64 over 1728. Now, how about the probability of having 3 black balls? That will just be equals to what? 3 over 12 times 3 over 12 times 3 over 12. And that will be equals to 27 over 1728. And finally, the probability of having 3 red balls will be equals to what? 5 over 12 times 5 over 12 times 5 over 12. And what would that give me? 125 over 1728. So now the probability of having 3 white balls, WWW, or 3 black balls or 3 red balls, since those are the 3 possible cases, just because of what? The probability of having 3 white balls plus the probability of having 3 black balls plus the probability of having 3 red balls. And what would that give me? For the white balls, I have 64 over 1728. For the black, I have what? 27 over 1728. And for the red, I have 125 over 1728. When you sum up all of this together, you get 216 over 1728, which is equals to 1 over 8 or 0.125. So to recap, we are told to find the probability that all the 3 balls are of the same color. So we know that there are 3 cases, or there are 3 conditions that can make 3 of them the same color, and that occurs if 3 of them are white, 3 of them are black, or 3 of them are red. So we found the probability of 3 of them being white, and since we have independent events, we just multiplied 4 over 12 twice to get that. We repeated that for the black, but we multiplied 3 over 12 twice, and for the red, multiply 5 over 12 twice. And now to find the probability of having 3 white or 3 black or 3 red, we just summed their individual probability, which resulted in 1 over 8, or in decimal 0.125. Now let's take a look at dependent events. So as the name implies, when you say 2 things are dependent, it means that they are related to each other and they affect one another. So 2 or more events are dependent if the outcome of one of the events affects the outcome of the other events. So for example, robbing a bank and going to jail. Yeah, they are well related events, because if you rob a bank and you are caught, then you are most likely going to go to jail. So these 2 events are related, so they are called dependent events. Fighting in school and being suspended. Yeah, if you fight in school, you have a risk of being suspended. So also, these are what dependent events, because before you can be suspended, you have to fight in school. So they relate, or they depend on one another. And finally, probability with replacement. So previously we talked about probability without replacement as being independent event, but now we will see how probability with replacement is what? A dependent event. So now the probability of A and B occurring, given that B is dependent on A, is given as probability of A and B is equal to the probability of A times probability of B given A. This sign here means given, so probability of B given A. So where probability of B given A is a conditional probability that is read as the probability of B given that A has occurred. So this probability of B given that A has occurred is an indication to the fact that event B occurring is dependent on what has happened when event A occurred. So we know that if they are independent events, then probability of B giving A has occurred is because to the probability of B, because B is not related to A. But in this case, value of B is related to the value of A, so we must take that into consideration when trying to solve questions. So let's take a look at this example. And here we are told that a box contains 4 whites, 3 black and 5 reds. I've tried to make use of the same example so that we can easily compare the results. So we have 4 white, 3 black and 5 red balls. So we know that altogether we have 12 balls. If a first ball is withdrawn without replacement, after which the second ball is drawn, find the probability that the first is red and the second is white. So now we are trying to find the probability of the first red and the second white. And now we can see clearly here that we have probability without replacement. So what does this mean? It means that what? They are dependent events. So the probability now of having red as the first and white as the second, because to the probability of having what? Red as the first times the probability of having white, given that red has already occurred. So now what does it mean when we are trying to figure it out? So if you look at it now, this is where the notable difference is. So what is the probability of picking the red ball first? So now the probability of picking a red ball will be equals to what? Probability of picking a red ball here is 5 over total number is what? 12. So this is the probability of picking a red ball. How about the probability of picking a white ball given that I've picked a red ball? What would that be? Now if we think about it, I withdrew one of the red ball. So I took one of the red balls out of this basket and I didn't replace it back like in the other case. So now that I didn't replace it, what is going to be the new number of red balls in that container? So I'm still going to have my 4 white balls, my 3 black balls, but now I'm going to be left with what? 4 red balls, because for my first draw I've taken one of the balls out. So now if I'm left with 4 balls, how many balls are remaining? 4 plus 3 plus 4, and that gives me what? 11. So now this is what I have left. I have just 4 red balls left and 11 balls in total left. So the probability of picking white ball now will just be total number of white ball here, which is 4, and total number of balls remaining. And as you can see, total number of balls remaining is 11 and not 12, because I've taken 1 ball out already. So as you can see, instead of having 12 in the denominator like we had when we were dealing with independent event, we see that this has reduced because this value here is dependent on the outcome of the first ball that is being drawn. So what would that be? So the probability of having a red ball as the first ball will be 5 over 12. Now the probability of having a white ball as the second will be 4 over 11, because I've taken one of the balls away without replacing it. So when I simplify this, what do I get? 4 here 1, 4 here 3. So I get what? 5 over 33. So the probability of picking the first as red and the second as white is 5 over 33. Now let's take a look at this final example. So here, a boy has 10 identical marbles in a container consisting of 4 red and 4 blue marbles. So he has 10 identical marbles and made up of just red and blue. 4 of them is red and 4 are just blue. So he draws 2 marbles at random, one after the other, from the container without replacement. So after it takes one, it fails to replace it. It does not replace it. So we are told to find a probability that A, the first is red while the second is blue. So now to explain it, you have the container and you have what? 6 red balls and you have 4 blue balls. So now you know that what this is without replacement. So you know that the probability of having red and blue now will be equals to what? The probability of having red, since they are dependent event, times the probability of having a blue ball, given that I've taking a red ball as my first ball. So now altogether I have 10 balls here. So at the initial stage, what is the probability of picking a red ball? I can see that the probability of picking a red ball is what? Just 6 over my total number. So my probability of picking a red will just be equals to what? 6 over 10. But now after I've picked one of the red balls away from here, how many red balls do I have left? I'm left with just 5 red balls, but my blue ball is still what? 4 blue balls. So now altogether, how many balls are remaining? 9 balls are remaining. So in this container now, what is now the probability of picking a blue ball now, given that I've picked a red ball initially, and that is why the number of red balls have reduced. So what would that be? Number of blue balls remaining in the container will be 4, and the total number of balls remaining in the container will be what? 9. So that will give me what? So here I have what? 6 over 10, right? So the probability of picking a red ball, so I have what? 6 over 10, and for the second ball I have what? 4 over 9. Then I can simplify. I know that 3 here is 2 and 3 here is 3, 2 here is 2 and 2 here is 5. And what does that give me? 2 times 2 gives me 4 over 15. So the probability of picking the first as red and the second as blue is what? 4 over 15. Now just as comparison, if these two events was with replacement, then I know that there will be independent events. So the probability would have been 6 over 10 times what? Because I will replace it back, so I will still have my 10 balls altogether times 4 over 10. But now because I'm not replacing the ball and I didn't replace the ball, total number of balls have reduced to 9. So that is why I'm multiplying it by 4 over 9 to get 4 over 15. Let's take a look at the other parts of the question. Second part asks us to find a probability that both balls are of the same color. So now, to give you, so this is the basic information. We have 10 marbles, 10 are red, 4 are blue, and 2 balls drawn without replacement. So the B part asks us to find the probability that both draws are of the same color. Now there are 2 ways in which both balls can be of the same color. So it's either I have 2 red balls or I have what? 2 blue balls. See, so what does it mean? It means I have to calculate the probability of having 2 red balls or the probability of having 2 blue balls. And from our addition law, when we have or, what does it mean? It means I have to add these 2 probabilities together. So let me start out by trying to figure out probability of having 2 red balls now. So now the probability of having 2 red balls without replacement. So now the number of balls will be equals to what? The first ball, probability of having the first ball. At first, I have what? 6 balls, 6 red balls and 10 balls altogether. So what would that give me? It will be what? 6 over 10. However, because I failed to reduce or to replace the ball that I took, what would I be left with? I'll be left with just what? 5 red balls instead of 6 red balls. And total number of balls, because I've taken one away, instead of being 10, I'll be left with just 9 balls in total. So the probability of picking red as the second ball would have changed to what? To 5 over 9. 5 here 1, 5 here, 5 here, 5 here 2. What am I doing? 5 here, 5 over 9. And what would that give us? So this gives us 2. Okay, although don't let me simplify. So I have 6 over 10 times 5 over 9. So 5 here 1, 5 here 2. 2 here goes, what do I get? I get 2 here. And 2 here, what do I get? I get 3. So what does that give me? 2 over 6, which is what? 1 over 3. So the probability of having both red balls with replacement is 1 over 3. How about the probability now of having 2 blue balls? The probability of having 2 blue balls. So for the first ball now, I first have 4 blue balls initially, which is then reduced, and I have 10 balls altogether. So it will be what? 4 over 10. But now for the first ball, I've already picked 1 ball. So I'm going to be left with 3 blue balls And since I've taken one ball, total number of balls would have reduced to just what? 9. So when I simplify, 3 here 1, 3 here 3, 2 here 1, 2 here 2, and 2 in 10 is 5. So I have what? 2 over 15. Right? Yeah, so now the probability now of having the balls of the same color, so probability of having red red or blue blue, because of what? The probability of having red red plus the probability of having blue blue. And what would that be? That would simply be equals to what? Probability of having red red is what? 1 over 3. And the probability of having blue blue is what? 2 over 15. If you find the LCM, see that is 15, and this becomes 5 plus 2, and that gives me what? 7 over 15. So the probability of having two balls of the same color is 7 over 15. And to recap, what I did first was that I listed out the number of ways in which I can have the same colors, and that is if I have both of them to be red or both of them to be blue. So I tried to find the probability of both of them being red without replacement, and that is why the values here decreased. So I got this, and the value for both of them being blue, and I got this. And finally, I just find the sum of both of them, because from our addition law, when we have or, we just sum it together. So let's move on to the last part of the question that asks us to find the probability that both of the balls are of different colors. So what are the two ways in which both of them can be of different colors? So there are two ways. So it's either the first ball I draw is red and the second ball I draw is blue, or the first ball I draw is blue and the second ball I draw is red. So these are the two conditions in which they can be what? Of different colors. And remember, all means I will add. So I can start out now by saying the probability of picking red first and blue second without replacement, because the probability of picking the red ball at first equal, I have what? 6 red balls and 10 balls altogether, I'll be what? 6 over 10. But now if I've taken one red ball out of the container and I fail to replace it back, how many balls would I have left? I'll be left with just 9 balls in the container. But since I've not taken any blue ball, the number of balls in the container will still be equal to before. So the probability of picking the blue ball now will just be what? Times what? I get 4 over 9. Yeah, and when you simplify this, what do you get? You have 2 here, you get 2, and 2 in 10, you get 5. Then 3 here 2, 3 here 3. And what does that give you? That gives you 4 over 15. Now let's do for the second case, the probability of having the blue come out first and the red second. So for the blue coming out first now, I know that at first there are 10 marbles and there are 4 blue balls. So for the first ball, it's going to be what? 4 over 10. Now for the red ball, I know that altogether there are still 6 red balls because the first ball I took out was blue. So I still have my 6 balls intact. But now, the number of marbles have reduced by 1 because I've already taken one blue ball out of it initially. So times 6 over 9. And when you simplify, 3 here you get 2, and 3 here you get 3. 2 here you get 2, and 2 here you get 5. You get the same result, which is what? 4 over 15. So the probability of having red first and blue second, or blue first and red second, is equal to what? 4 over 15 plus 4 over 15. The all means we add it together, and that gives us 8 over 15. So the probability of drawing two balls of different colors is what? Simply 8 over 15. So that pretty much sums up our discussion on probability. So you notice now that the only way in which you can really master questions that have to do with and without replacement is by practicing. So I will urge you to go through this section again and try to understand the major difference so you're able to tackle questions. So that will be all for now. In the next section, we'll be looking at some past questions to see how to apply some of the questions that we've solved.